of the best player who has to shoot a ball that's what was 1 meter above the ground, and we wanted to know if it's going to go over the fence or not. And we were able to solve a problem for motion in 2 dimensions. I'm going to start today's class by a little exercise for you guys. So I want you to form a group of 3 or 4 and start solving that problem together. I'm going to go by and I'm going to observe your solution. So form a group of 3 or 4 and start solving that problem together. It's not going to be graded, but I want you to discuss the problem together until you reach a solution. So feel free to move around and to turn the chairs and sit in a group, and girls do not have to gang together against boys and sit together. You can just work in a group of boys and girls. Groups. I see one group has been formed. Yes, feel free to move the chairs. Feel free to move the chairs. Chill out. This is a Saturday, so consider it a weekend, and we're spending just the weekend together. It's not a regular class. That's okay. You did not miss much. We're gonna go over it again. You will know. Yes, Sharif knows. Nagy knows. They know, and if they do not tell you how to do it, tell me. I'm not gonna punish them, but I'm gonna help you out. Well, solve in a group. So read the problem, discuss it together, put a strategy. How are you gonna actually solve that? Then after we finish, each group will have only one answer. So you have to convince your colleagues by only one answer, and we're gonna vote which one is the right answer. Yes. Oh, okay. And those are the 3 kinematic equations. Does velocity equal distance times time? Who said yeah, Nagy, come on. Does that's what I'm saying is, does velocity equal distance times time? This equation correct? So someone saying velocity equal distance over time, this equation correct? Yes, it's correct. This is correct. This is not correct. And you can actually check that by your units. Just check the units and you know that this equation is not correct. This is correct, but this is not valid all the time. It has to have a condition. This is valid only at some specific times. When there is no acceleration. Oh, I forgot your name. Nada? Nada saying, oh, actually this equation is only d equal to vt, which is similar to this, only if there is no acceleration. Compare the 2 equations. This is that, this equation, exactly that, if only there is no acceleration. Thank you. Okay. You have to be part of it. Oh. The point is, you should talk about the problem. You should discuss the problem. Not only one of you will solve the problem and the rest are watching him. Guys, and I didn't want you to actually, each one of you to solve the problem by himself. I want you to leave the pen or the pencil, read the problem, discuss it together. Then one of you only has to write. Guys, I want you to elect a team leader, and the team leader is the one who will have the pen or the pencil. And he's the one who's gonna actually lead the discussion. He's gonna be the moderator for the group. Guys, talk together. Sit in here. Okay. So read the problem, discuss it together. Then agree on a strategy to solve the problem. Then start solving. Good. This is good thing to do. What will be the location of thrower number 2? How far away from the thrower number 2 will the receiver? How far away from D2, thrower D2, will the receiver of ball 2 be when he catches it? Let me read again. Yes. Two footballs are thrown from the same point on a flat field. Both are thrown at an angle 30 degrees above the horizontal. Ball 2 has twice the initial speed of ball 1. If ball 2 is caught at a distance D, you catch ball 2 at distance D1, and you catch ball 2 at distance D2. Find the relation between D1 and D2. Does D1 equal to D2? Does D1 equal to 2D? D2 equal to 2D1? D2 equal to 4D1? D2 equal to 8D1? Which one is the correct answer? Will they? Will they have the same time? If they travel different distances, and I don't know, maybe not. But the distance does not equal to velocity in time. This is only valid if there is no acceleration. Do we have acceleration? Oh, okay. So in which direction are you talking? X or Y? X? Yes. Then this equation is valid. Yes. Yes. Oh, okay. Okay. But the most important is not to convince me, it's to convince them. Guys, though I think that all of you are very good students, but I think you are a very bad team. So I want you to discuss the problem together. This is the key point. I'm wasting the time so you can talk together. So who's the team leader? We have 3 team leaders. The team leader is the only one who can actually write. Oh, where did you get that equation from? Okay. Oh, okay. But you know, it's valid, but are you going to memorize it? Because it's not going to be in the formula sheet. So if you're going to use it now, you have to put it in the You have to draw. You have to drive it. If you're gonna use it, then you have to drive it.
I can't use it exactly.
I don't want you to memorize anything.
No, we not. We want to convert both of them.
It's them, not me. Them.
Yeah, we want to convert both of them. Yeah, sorry, one. Wait. Yani, we want to take this out because the same is zero. Initial zero. Single one. Yeah. We have V naught 1 3 equals 2 V naught T, right?
But did you say that they will travel the same distance? They will not travel the same distance. That's what I'm asking.
Yeah, the initial distance.
But this equation and that equation, what you're doing now is you're equating x1 to x2 or d1 to d2. You're enforcing that, you're saying that d1 will equal to d2. And this is not the case. That's what I'm asking. What is the relation between d1 and d2? And if you look at the answer, none of them will give you what you have assumed. Right? Right? Mai?
Yeah. So then we don't use the x, we use let's use.
Now you can use that x, but your x1 does not equal to x2. Or d1 in the terminology of the problem does not equal to d2. Right?
Yeah.
I'll come to you. Right? And remember, this is a motion in 2 dimension. You throw a ball that like that, so it's a motion in 2 dimension. It travels a distance d1 first of all, and the other one it travels a longer distance, maybe a longer distance d2, and that depends on the velocities of the two of them. The first one, it goes with the velocity v1, initial velocity v0, which is not given. The second ball will start with the initial velocity twice v1, v0, v10. v10, I mean the velocity for the first ball, the initial velocity of the first ball. The second ball will start with the initial velocity twice of that of the first ball.
Yeah, that's what here says 2v2.
Yeah, but that equal here, that was the wrong part of it. Or you should actually calculate x1, calculate x2, and look at them. Oh yeah. Yes.
Can I answer this? But in all the same time.
Are they? What are those two
Doctor,
t's?
I do d1 equal d square على 4 root 3.
What is that? What is square 3? What is the square root 3?
Over 2 times 2 equal root 4.
That's the cosine of the angle?
I say d1 على root 3. بعدين عملت okay? I can't cancel تي مع تي. بس هيطلع ان دي 1 equal دي 2 اصلا دي مش اوبشن من الاوبشنز الموجوده عندي. ما هي كانت احنا دي 1 ودي 2 اصلا.
Sorry. d1 equal to
دي سكوير
v square
دي 2
v2 times
root 3
cosine theta, right?
root 3 على 2
Times t, correct. And d2 equal v2, okay?
Okay, d2 equal root 3 على 2 multiplied 4 d1 over root 3 على 3 multiplied t. Can I cancel t with t?
Oh, then you're assuming that they will travel at the same time. Are they going to travel at the same time? So you cannot cancel T with T because those are the two different times. Then you have to solve for T. You have to solve for T for each one of them. You have to find T1 and yes, if you find T1 and T2. Yes, if you find T1 and the T2. You are on the right track if you find T1 and T2. Good. Are you done, guys? In the equation. Yes, that's good. Yes, you got the right answer, the right approach, because it starts from a horizontal point and ends at the same point, the same level. But the key point is you have to get that equation. And if you start the physics from the beginning, trying to find the distance d1 and trying to find the distance d2, you will not need to get that equation. Now what you're trying to do is you're sitting now trying to remember what did we do yesterday or on Thursday, and this is the wrong approach. It's displacement. Yes. No, why not? Oh, along the y, but we're talking about displacement along the x. When I throw this, yeah, but we're talking about displacement along the x-axis. There is displacement along the x-axis. Okay, so displacement along the y is 0.
عندنا بنقسم البروجكتايل الاكس والواي، فمثلا زي البتاعة دي هي مثلا بتبقى ساين 30 للواي وكوزاين 30 للاكس. ايه الفاليو اللي هتحطها قبلها كتير؟
The initial velocity. Yes, which is not, it's given here, it's V initial, VI, but it's not a numerical value. But it's given. So guys, do you have an answer? Okay, let me see. What did you do? You said x1 equal, that's good. x1 equal blah 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 times, how did you get that? How did you get that? How did you get it? That's what I'm asking. What did you do? What is that? How did you get it? Explain to me. How did I get it? Oh, then you have to find out. How did you get it? I think there is a mistake in here. You're on the right track if you put that equation correctly. If you put time 1, T1 correctly, you're on the right track. Then you have to find how did we get that time. Guys, do you have an answer? What is it? B. Let me see your solution then. Okay. D1 equal to V0 times T cosine 30. D2 equal V0 cosine 30. What's 2 twice? Correct. Then?
I calculated that the time will be double 2.
Why?
So
Why the time?
The V along the y-axis will be double, so it takes double the time.
Wait. Because what?
The V along the y-axis will be double, and the V naught will be double. So it will take double the time to reach the ground again.
How do you know that?
This issue. I calculated that V equal 1 times
Perfect.
0.
Perfect. Good.
So made the ratio double time, double distance.
Yes.
Ratio between them.
V0. This along the y-axis?
Yes. I said that the V final will be 0.
At the top point. So you're not going that way. You're going. Can I do this? You're going that way. So you're saying this is the velocity at that point. That's what you're saying. The velocity at that point, which is going to be 0. So I would write it to make sure that the grader would give me the right grade. Vy equal the velocity along the y-axis. V0y plus a yt. This is 0. That's what you're saying. This is 0 equal V0y, which is V0 sine theta
30.
sine 30 plus
AY
negative g times t. And you're now getting an equation for t and replace V0 by 2V0 and you get a relation between T1 and T2. And put them in here, T1 and T2, because this is T1, right? And that's T2. Unless you're forget that for now. Then you get the answer. That's a good way to do it. Very good. That's a good solution. I'm sure that this is also another good solution. I don't prefer any one over the other one. There is a solution and there is another solution, but there is nothing called the model answer or the best solution. Oh, that's good. R, which is the range, equal to blah, blah, blah. How did you get that equation? Oh, but that was a problem. And that means that you're memorizing that equation. Yeah, but still, if it's not there, it's not going to be in the formula sheet. That equation is not going to be in the formula sheet because it's not a basic equation. So you have to prove it. If you want to use it, you have to prove it. But that's the same way as he did. Actually, he proved that equation in the way. So if he does not use numbers, he will get that equation. And if he does, so your solution, you guys, is exactly the same. But he started from scratch. You were a little bit lazy, so you got the final answer and you plugged in the values. But your solution is the same. Do you see it? Do you see it? You have to, because if you want to learn physics, then you have to actually start any problem from scratch. Memorization is not good. Do you have a computer? What is the capacity of your hard disk? And can you fill that 160 by information? Yes. At one day you're going to fill it. And if you want to put some more information, what are you going to do? Erase some old information and put the new ones. This is exactly our brain. So if you're going to keep memorizing, you have to erase information and put some new information. And I don't want you to do this. I want you to put only the necessary information in your head. That's what you want you to memorize. And you're going to memorize the physics, not equations. Because when you graduate as an engineer, you can find the equation in the book. But how to use it, that's going to be in your head.
If I know the proof, I don't want to write the answer sheet.
Why not? We have plenty of papers, and I can give you my pen or pencil. So you should actually write as, you should prove it. This is how you learn. But if you, in the exam, if you give me that equation, he will get 10, you will get 2. The same answer. Same answer. I know that you understand what you're doing. I know. But you're memorizing. And I don't want you to memorize anything. Okay? Good. Good, guys. I know that. I said you're good students.
I did it another way.
Okay?
A bit long.
Okay?
I did it at home.
You did at home.
Yeah.
Okay, good. Okay. But now, at least, at least you see other views. That is one good thing about group work.
Yeah.
Okay. Do you want to show me how did you do it?
I got the half distance and the half distance from here. I set like the time equal to 1.3 and 1.6, and then I made it times 2 for each, and it came B.
Okay.
But it was a bit longer.
Okay. Yeah. Guys, are you done? Did you finish? What's the answer? A. Okay. Do you have an answer? What's the answer? Do you have an answer?
I think انها دي بس هو مش مقتنع. انا بلعب من نفس الحاجه فممكن انا حاجه
Okay.
ممكن اقول x equal to x1 t1 طب يعني انا لو انا جيت بقى عايزه اجيب t1 وال t2 relation بينهم كان هيجيب لي x equal دي لا t1 equal دي
Oh, why not? Yes. All what you have to do now is to go find the relation between T1 and T2. Okay, I'll teach you how. Do you have an answer? A. You have a problem?
Do it again. To do the time. The time it turned out to be the same.
I'll teach you how to do it. Okay, guys, let's vote. Group number 1, do you have an answer? Yes. What is the answer? B. So B has 1 vote. A has also another 1 vote. 2 votes. B, 2 votes. No, you have to tell me an answer as a group. A. Okay, so 4 A's and 2 B's. Let's solve it. Now you have your solution. I'm gonna do my approach and we'll solve it together. We'll see. And if you have something wrong, you tell me where did you go wrong. Okay, guys? This is pole number 1, it travels a distance d1, and pole number 2, it travels with the same angle, but double the velocity, so it travels a distance different d2. The diagram is just a schematic, does not represent the answer. That's d2. And we need to find the relation between d1 and d2. So d1 obviously it's a distance or a displacement along the x-axis. So I'm going to say that d1 equal to x0, 1, the initial position of the object, 1, plus v0, 1 along the x-axis, the initial velocity for along the x-axis for object number 1, the 1 represents the object, t1, the time it took to travel that distance, t1, plus half ax blah blah blah. There is no acceleration on the x-axis, that's why I'm not going to write that term. And I start from 0, so this is d1. d2 will equal to v0 2x t2, the initial velocity for the object number 2 along the x-axis. So what is, if this is v0, v0x will equal to v0 cosine theta, and v0y will equal to v0 sine theta. So I'm going to replace v01x by v01 cosine theta and v02x by v02 cosine theta. We know that v02 equal to 2 v01. That's what's given twice. The initial velocity for object number 2 is double the initial velocity for object number 1. And I'll keep that to the end. Now if I can relate t1 to t2, t1 to t2, I will get an answer. So let's find the relation between t1 and t2. We know that to reach that maximum height, the velocity at that point will equal to 0. And that time is going to be t1 over 2. And that time is going to be t2 over 2. Because when you throw this, it takes half the time to reach the end, to the maximum displacement along the x-axis. If you take time t to reach half of that, you need time t over 2. So I'm going to say that the Vy1 at the maximum point equal to V0y plus half G T1 T. Okay. Vy V0 Y1 T1. That's correct. I'm saying the velocity along the y-axis for object number 1 will equal to the initial velocity for object number 1 along the y-axis plus half g t1. Am I right? No, there's no half. Plus g t1. Okay. Oh, there's just an equation. I said that equation we know it. V equal to V0 plus AT. Right? Right? So I'm just translating that to object number 1 along the y-axis. Okay? So I'm saying the velocity along the y-axis for object number 1 will equal to the initial velocity for object number 1 along the y-axis plus the acceleration times t1. Okay? And if I talk about the velocity at the maximum point, which is going to be 0, correct? Will equal to V0 sine theta plus minus G times T1. What's T1 in that case? It's T1 over 2. That time. That's T1 over 2. Then we can say that T1 will equal to V0 sine theta 2V0 sine theta over G. 2, the time to reach that point for object number 1, it's going to be 2V0 sine theta over G. Okay, guys? Okay? So I know also that D, the distance, either D1 or D2, distance in general, the maximum range in general is going to be equal to V0 cosine theta T1. So D is equal to V0 cosine theta and T1 is equal to 2 V0 sine theta over G. Now look at that equation. D will equal to 2 V0 squared cosine theta sine theta divided by G. This is the equation that you're trying to reach. This is for the range, and this is the same thing. So I got the equation, and actually our colleague, I forgot your name, Hassan, has gotten that equation without actually doing this. He just substituted by the value of T1 and T2 here, and he got the answer as well. So he did not get that. But I got now that D. So if I want to translate that to D1 and D2, then D1 will equal to 2 V0 squared times cosine theta, sine theta, I know, divided by G, and D2 will equal to 2. What's the velocity along the y? What's the initial velocity for the object number 2? It's twice V0. So it's 2V0 squared. 2V0 is twice of that. If this is 1V0, for object number 2, the initial velocity is twice of that. So I'm writing it 2V0. Correct, guys? Right? You do not understand? Do you get there? I got D for any object. I said, what I did is, what I said is, they travel the same way. One of them has an initial velocity more than the other one. So I'm going to pick any one of them. And I'll find the equation that describe, guys, d for any one of them. So the d, which is the distance along the x-axis, will equal to the initial position plus the initial velocity along the x-axis times t plus 1/2 a t squared. And a is the acceleration along the x-axis. I'll cancel that because the acceleration along the x-axis is equal to 0. I'll cancel that because I start from the origin. So d will equal to the velocity along the x-axis, which is v0 cosine theta. This is v0x times t. Okay, I'll keep that. Now let's find the time t for that object, any object, to reach that point. You start from that point, and then we want to find the time t, that whole time t. Okay. I said to reach that point, the maximum point, it's going to take time t over 2 here and t over 2 in the second half. So I said the velocity along that point is 0. Along the y-axis at that point is 0, which is equal to the initial velocity along the y-axis plus ay t over 2. Right? Right? Guys? Okay. So 0 will equal to v0 sine theta. This is the velocity, initial velocity along the y-axis, plus negative g times t over 2. And from that, t will equal to v0 sine theta times 2 divided by g. Then, in this equation, I replace t by its value. I will replace t by its value. Then d will equal to v0 cosine theta times t, which is 2 v0 sine theta divided by g. And this equation here, it's exactly that one. And it's also that one. I just combined those together. Okay? Then now I'm translating. If I'm talking about distance d1, then I'm going to talk about v initial for object number 1. And if I'm talking about distance number 2, I'm talking about v initial for object number 2. Correct? Times cosine theta, sine theta over g. Now, what's v01? What is the initial velocity for object number 1? Give it any symbol. X. U. It's U. Okay? What is the v initial for object number 2? 2u. Now, what's d2 over d1? If you divide that by that, this equation by that equation, that's what you get. This cancel. Correct? Cosine theta cancel. Sine theta cancel out. G cancel out. You end up having 4u squared divided by u squared. So what is the relation between d2 and d1? Okay? It took longer time for me to explain it, but some of you have solved it in a much, much shorter time. But this is the way. Now we have learned again how to find R, the range, and all motion in 2 dimensions is exactly like that. You have to separate the motion on the x-axis from that motion on the y-axis. This equation here, that describes the motion along the x-axis, and this describes the motion along the y-axis. We separated them, then we got the time from the motion along the y-axis. We substitute by the time in here, we get an answer. Excuse me? I don't remember. We'll see. And what's T2? What is T2? That's what I'm asking you. What is T2? And that's T1 and that's T2.
بس انا عملت بينهم substitute بعد كده جبت السي حضرتك جبتها لي T1 equal to
What you have to substitute for T2 as well. Same way you got T1. You didn't actually need now that's what you did. This is the answer. No, I said here I'm solving it for any object. Guys, I did not solve it. Now when I solved it the second time when Farida asked me, I solved it for any object. It doesn't matter how long it did travel or how long it took to travel that distance. I said the distance for any object that's gonna travel as a projectile will equal along the x-axis is gonna equal to v0x times t if it starts from the origin and then there is no acceleration along the x-axis. And this is gonna be the equation. Then d will equal to v0x, which is v0 cosine theta times t. T is general time, any time for any object. Now, to find that time t, I said that the velocity along the y-axis at the topmost point is equal to 0, which is equal to the initial velocity along the y-axis plus the acceleration along the y-axis times the time over 2. The time it takes to reach the topmost point, which is the total time divided by 2. And from that equation I got t. Then I substituted by t in here. I get that equation for d, which is not function of time now. It's function only for in the initial velocity and the angle. Let me finish. Now, this is a general equation. Now I am going to use that equation to find d1 and d2. Then divide d1 by d2. Yes, I know. That's why you have to find T2. And T2 is going to be 2. If you want T, find T2. Don't listen to us. That's only for, what's your name? Aya. This is only for Aya. T2 is going to equal to 2 times, what is the initial velocity for object number 2? It's 2v0 sine theta over g. If you do this, you get the same answer. Which one? That one? Okay. That's a good question here. It travels that way, right? At the maximum height, what is the initial velocity? Sorry, what is the final velocity? What is the velocity at the maximum height? 0. So actually I should have written this is Vy at maximum point. Yes. Sharif.
In the equation where we don't have the d.5, we didn't have the d divided by 2.
In the equation what?
Like the equation that we're using is d squared, dx squared is equal to d0 sine whatever squared.
That's what we got last time.
Exactly.
Yeah, because last time.
We didn't have the t divided
Yes,
by 2.
of course, because last time I said it's going to take time 2t to reach that. So this is going to be t and this is going to be t.
Initial velocity
This is what we did last time. Okay? On Thursday, we said that it's going to travel a distance d, and it's going to take time 2t. So this is going to be t, and this is going to be t. It's exactly as if we say, this is time t, and this is time t over 2, and this is time t over 2. Okay. Along the y-axis. Yeah. If this is x and this is y, and this is the initial velocity v0, and this angle is sine theta. Sorry, this angle is theta. This is the component of the initial velocity along the y-axis, which is, how can you get that component? If you know the vector and an angle. What is the y component of any vector? Guys, what is the y component of any vector? If you have a vector, can I erase this? I don't need all of that now. Maggie, if you have a vector A, and if you know the magnitude of that vector, which is the length of that vector, and that angle theta, can you find the x component of that vector? Nagy. Okay, tell me. We need to find the x component of the vector. Nagy, we call that part, this part, we call it ax. Okay? And we call that part, if you take a perpendicular in here, we call that part here ay. Look at that triangle, Nagy. This is the same as that one. This is also ay. Look at that triangle, that shaded one. Okay. What is cosine of the angle theta for that triangle? Adjacent, so it's going to be ax over a. Okay, which means that the x component of that vector equal to a times cosine theta. Okay? Okay. So now, look at this. What is the sine of that angle theta? Sine of that angle. Opposite, which is ay, divided by a. Which means that ay will equal to a sine theta. So for any vector, the x component of the vector, if you know that angle, theta, the x component of the vector, it's the vector itself, the magnitude of the vector times cosine of the angle theta, and the y component of the vector equals to the magnitude of the vector times sine theta. And that's what we did. This is the vector v0, initial velocity, and we know that angle theta. So the x component of the vector v0 will equal to v0 cosine theta, and the y component is going to be equal to v0 sine theta. And that's what I did. No? It can be. No. Nagy. This is x, this is y, this is vector A. And that's the angle theta. And sometimes someone else will say, no, this is x, this is y, and this is the vector A, but I'm going to choose that angle to be my theta. In here, ax will equal to a cosine theta. While in here, ax will equal to a sine theta. So it depends on where is your angle. Okay? Here AY is going to be equal to A sine theta, while in here AY is going to equal to A cosine theta. So that depends on where is your angle. And if you really want to understand it, this is by drawing the triangle and finding the cosine and the sine of the angle, and you'll get the x component and the y component. Yes.
Second question. The key we got equals to 2 v naught sine theta over v.
Mm-hmm.
Is the time for
Half.
so
Half the range.
when we substitute it to
No, I'm sorry. No. Time is this is the time for the whole distance. Because when we put that, if you remember, you
the equation we
t over 2. When we said, when that was the projectile again, right? So I said it took time t to travel that distance, and it took t over 2 to in here, and t over 2 to travel that part, and t over 2 to travel that part. And I said in that equation, look at that equation, the velocity at that point will equal to v0y plus ay times t over 2. Then I found t. And when we find t, this is t. We did not find t over 2. Okay? Sure. Okay guys, that was very useful, I guess. That was a very useful exercise. So we still have like 15 minutes. So what I'm gonna do is, do you have any classes after that? Okay. If it's 5 minutes, then what I'm gonna do is, okay, guys, this is shooting the monkey. This is the simple demonstration. It says that if you have something that falls down under the gravity, falls down without initial speed, initial velocity, how can you aim at that thing and shoot it? If you have something that drops, assume that that projectile is going to drop. Yeah, they're not moved, it's not going to drop. And I want to actually shoot that projectile. Should I aim on it, or should I aim a little bit lower? Because it's going to be dropped. At the time it starts to drop, the bullet is going to go out of my gun. Should I aim at it at the most top point, or should I aim a little bit lower? Farida? Yeah, when I shoot, it's triggered. When I shoot, it will start to fall. Same time. It's synchronized. So when I shoot the gun, somehow it listens to the sound and it drops. Should I aim at it, or should I aim a little bit lower? Lower. This is a very, who said lower? Lower.
Depends on the gun. Is it going straight or is it going in an arc?
Oh, you're gonna shoot on it. Oh well. Oh, that's a good question again here. If I aim that way, will the bullet go in, move in two-dimensional motion as a projectile, or it will move straight? Of course. No. No. It will. If there is a gravity, then it's gonna go straight for a small part. Then it will take that. And if you look at that part in here, you see it, that small part in here, it's almost a straight line. But actually it's not a straight line, it's part of that parabola shape. So the bullet will follow the same trajectory, exactly the same trajectory. Oh, it's still trajectory, it's part of the trajectory. It is part of the trajectory. Let's say it's not a bullet, it's a ball. I'm gonna throw a ball in it, just to make you feel it. Okay, so you can sense it. Okay, And let's assume that if it's a bullet, then it's somewhere at 3 kilometers. That projector is 3 kilometers away. If it's a bullet, so you can actually, so your brain can absorb that. Then you're saying that I should not aim at it, but I should aim a little bit lower. I should aim higher. So now we have 3 answers. So Farida is saying you should aim higher, because if you're going to aim higher, it's going to go down anyway, and they will meet at some point. And that's one answer. Does anyone have another answer? Yes, wait. Higher. Does anyone have another answer? We have only 3 answers. Either higher, or you should aim at it, or lower. So, guys, concentrate with me, please. Would you please listen to me? For a minute? Let me just at least moderate the talk so we can all hear each other. So in order to hear one of you, I will not be able to hear the other. So I need only one talks and the other will listen to him. At least we should listen to other ideas. So I'm going to summarize what are the 3 cases that we have. Then we're going to vote on them. Then I will allow everyone to explain why did he choose that vote. Okay? We should aim higher. We should aim at it. We should aim lower. Those are the 3 answers. Higher, at it, and lower. So who's in for higher? Who thinks that we should aim higher? Just raise your hand. Farida?
I don't know, because it depends on the
Look, we should aim at it. We should aim lower. Okay, slightly. It doesn't matter. It's lower. Okay, we're assuming that the initial velocity along the x-axis, we're assuming this is an assumption, the initial velocity along the x-axis has to deliver that object to that. So the range cannot be lower than that distance. The range, because I can do this, I can aim at it, I do this. I'm assuming that the initial velocity along the x-axis has the magnitude in such a way that at least it will reach the projectile. Okay, if I want to aim at that projector, I can do this. I'm aiming at it now, at it or higher or lower, doesn't matter. But I give it a very small initial speed. Initial speed is not that much. So it reaches only here. Okay? Or I can give it a little bit of a push, higher initial speed, so it reaches it. So what I'm saying that the initial speed along the x-axis at least will make it to that distance. At least. Okay? I'll say it again. The initial speed along the x-axis will make it at least travel that distance. The projector is here. It can travel that distance. This is the least distance it can travel, or can travel more distances. Oh yeah, but at least it's going to travel to that distance. Now, should I aim higher, lower, or I should aim at it? Yes.
It depends on, like if you're quicker close to it, you're going to have to aim higher.
Mm-hmm.
But if it's further away, or
No, it does not depend on the distance D. Can we run the demonstration? I'll show it to you. As a demonstration, I'll aim at it. I will aim at it, then I will aim higher, then I will aim lower, and we'll see.
I can prove why at this right.
Yeah, I can prove it too. But let's look at the demonstration first. Okay, demonstration first. Hani, is it adjusted? Did you try it in the lab before? So hopefully, because actually this is very sensitive. I'll show it to you guys. We'll show it. Don't worry. I'll help you. I'll help you. Okay. Okay, this is the pool monkey. Yeah. So this is an electromagnet. We have, excuse me. We have an electromagnet in here. When we put current in it, it's a device. It becomes magnetic, so it attracts that piece of iron on that toy. And it's synchronized somehow with this trigger. So when I push that down, the bullet goes out, and the toy gets dropped at the same time. They are synchronized. So I don't know. So I'm not sure if we're aiming at it or not. It needs a little bit of adjustment, and sometimes when we move it from the physics to here, it gets messed up. So I'll try it and we'll see. Okay. Okay, guys, we'll see. Let's try. I don't know. No, I don't think so. We'll try again. We'll try again. You can move in here if you want to see it actually more. Or you can come behind me if you want to see it more. It hit. It hit. No. No, they are synchronized. That's why we put that piece of device in here. They are synchronized. That's why we put that electronic circuit in here. They are synchronized. The same time it gets, that one goes out, the toy drops.
الدايرة هنا بتفصل لما انت تعملها
Yeah.
زي تلحق وترجعها. شوفها من هنا انا عايز اقف لك هنا عشان
Okay, one more time. Hang it. It hit. It hit. So actually I'm aiming at it and it hit. So now I'm gonna change that. I'm gonna aim higher. You wanna see it more, guys? You wanna see it one more time before we change the angle? Excuse me? This is, I'm aiming at it. We'll have adjusted that before we come to class. We're aiming at it, exactly at it. We did not calculate that. Just a demonstration. We did not calculate it. But we can, if we want to. We can actually measure the velocity if we want to. Can you tell me how can we measure the velocity? Can you give me an idea? I'll actually mark it when it will hit that same level again that went up from. I'll mark it where it went, and if I know that distance, d or r, I can calculate the velocity from that equation. We'll measure the d, and we can measure the angle. So, yeah, then we have only v to calculate. Yes, we can measure y, d, x, y, x, and the angle from that assembly, and we can calculate the velocity. The weight is the weight factor, is the mass factor. We talked about that last time. We can calculate. We can measure the time as well. No. It hits. So sometimes it doesn't hit because it's not stable. So it moves while I'm moving. That's why it's sensitive. Now I'm gonna aim higher. It was I was aiming at it. Okay, honey. Okay, okay. It missed. You know, it went above it. It did not go. It did not meet at that point. They went above it. So when I aimed higher, it will go above it. I will aim lower. Should I try that one more time so you can really see it? We'll see it one more time. One more time. Sometimes because it's a very short distance and moves fast, we cannot really look at it. It went above it. Just barely missed it if you look at it. So I will aim lower. I'm aiming much lower. It didn't. So we can learn from this observation only that we have to aim at it if it's going to fall only under the gravity. And guys, this problem is in the slides. Please read it because we're going to start from part 2, chapter 4 on Monday. Now you can solve the assignment. Homework 2. And homework 3, I'm going to post it tonight. I'm going to post also the solution for homework number 1. And thank you for coming.
Homework number 2 is with you on Monday?
Yes.
Okay, I have a problem that will not be able to come on Monday. So could I post it tomorrow?
Send it with, yes, you can give it to me tomorrow. Or you can,
And I need you to explain to me what we had done the last session on Monday.
the last session, it was only what we have done today, nothing more.
Okay, and what about Monday?
Monday, next Monday?
Yeah.
So how about you come to me on Tuesday and we'll explain it to you. Or Wednesday.
Tomorrow is not possible.
Tomorrow I have so many appointments tomorrow.
So it's Tuesday.
Or Wednesday.
Could we have Tuesday morning because I have...
I'm here Tuesday morning. Yes.
We have a class on Tuesday, right?
No. Oh yes, we have class at 2 on Tuesday.
The normal.
Yes.
Okay, could we have an appointment, for example, at 11:50?
11:30? Okay, good.
Saturdays and Tuesdays.
Excuse me?
We're taking Saturdays and Tuesdays.